This is Ashored Innovations. Aaron Stevenson. Aaron?
And Ross Arsenault.
So as Ross mentioned, I'm Aaron Stevenson. This is Ross Arsenault. We're two of the co-founders at Ashored Innovations, an ocean tech company developing innovative solutions that improve the sustainability of the commercial fishery around the world. To provide some context for our presentation, we've prepared a short video that we'd like to share with you, and it kind of talks about some of the problems found in our own backyard.
Canada, the home to 1.7 million square miles of open ocean and more than half of the world's coastlines. On its eastern coast, you will find 4 small provinces, known as Atlantic Canada. This mighty region is responsible for 78% of the nation's fishing catch. World-renowned for its premium cold water product, Atlantic Canadian seafood occupies a large space in American, European, and Asian markets. With an incredible $3 billion in annual seafood exports, Atlantic Canada has a thriving ocean economy that is rooted in a tradition of both hard work and pride. However, the future of this industry is currently under threat. Increases in rope entanglement for species like the North Atlantic right whale and dangerously high pollution from lost fishing gear are having detrimental impacts on the region's natural environment. 640,000 tons of ocean waste and plastic comes from lost fishing gear, and 83% of right whales bear the scars of rope entanglement. Fishing gear has directly led to 85% of right whale deaths since 2015. Global estimates predict that almost 140,000 marine animals are killed every year due to fishing rope entanglement, and Atlantic Canadian fishers have been the first to face the consequences. The Canadian government has begun implementing 15-day fishing zone closures as endangered species are detected in the area. Already constrained to a limited season, these closures are tremendously costly to affected fishers eager to earn a living at sea. Estimated between $75,000 to $1 million in lost revenue per closure, each fisher has a large financial incentive to quickly find a solution.
This may be the single largest problem of our day, the struggle between economic gain and environmental cost. We're not just about saving the 450 endangered whales that swim the waters along the Atlantic coast. It's a global problem with far-reaching socio-economic implications. While the philosophical, ethical, and perhaps even moral implications of this are debated at the highest levels around the world, the inhumane deaths of these whales reminds us that this is a very real, tangible, and highly urgent problem for today. One that exists in every seafaring nation around the globe. And the question remains, how are we going to prevent marine animal entanglements and stem the tide of lost and abandoned traps lost and abandoned fishing gear that line the coastal waters around the world, while still preserving the livelihoods of the 58 million people that make their living upon the seas and make up the small coastal communities along our shores that rely so heavily upon the fishing industry for survival? Well, we have a solution. While it doesn't fix the whole problem, it does address the immediate problems of fishing rope entanglement and lost and abandoned traps. And to do this, we've developed 2 products that work together as one complete system. With an integrated hardware and software approach, this underwater buoy system clears the water column of the millions of vertical lines that run from the seafloor to the surface, providing safe passage for marine life and surface vessels, and significantly reduces the number of traps and gear that are damaged at sea, while also tracking the individual gear components, resulting in a drastic reduction in the number of new, lost, and abandoned traps left behind in the oceans. So the first product we call MOBI. It's a bottom-bound underwater rope containment system for use in trap fishing. The MOBI keeps the vertical The MOBI keeps the vertical rope and buoy contained on the ocean floor until the vessel is in the vicinity to retrieve the gear. Upon approach, the fishers send down a proprietary signal to activate the release, and once activated, the rope and the attached buoy rise to the surface where fishers can use their existing equipment and gear and processes to retrieve their catch and reset the MOBI for redeployment. And of course, you can't use what you don't have, and this is especially true at sea. So we've designed it to not only be effective, but practical as well, with features like its fully stackable design. And if your gear is 40 fathoms underwater, you need something to tell you where it is. Our Atlas product is a gear tracking system built on RFID, which automatically tracks and records the location of the gear, including when and where it was deployed and retrieved, and what pieces of equipment are connected together, along with the tag, license, and other regulatory information. The Atlas system presents the information visually in a manner that is both easy to see and understand. Beyond this, a subset of the information can also be made available to regulatory agencies managing the fishery and to other vessel operators in the vicinity so they're aware of the types and locations of the gear below the surface so it doesn't get caught up in a bottom trawl or tangled up with other trap gear, for example. But one thing that we've learned in talking with fishermen is that everyone has a secret spot that they like to fish and they don't want anybody else to know about it. Our system respects this competitive intelligence by limiting the visible locations on the screens to what could be seen with the human eye in a traditional surface buoy setup. And I'm pleased to report that while Ross and I are here enjoying the wonderful hospitality in Savannah, our third co-founder is back home conducting open water testing on our first set of working MOBI and Atlas prototypes ahead of our pilot scheduled for later this month with our partners at the Coldwater Lobster Association. Ross?
So when it comes to partners, it's an interesting field we're playing in. We have the government and regulators as well as the fishermen themselves. Now, these two bodies are often at odds and have different motives, but at the end of the day, a singular solution can unite the two. And that's where we found in. We've surveyed both the needs of both sides to develop a solution that's not just going to be benefiting the fishermen and not just going to be benefiting the government and regulators, but one that benefits both sides. And so action's been made recently by government agencies, especially in Canada, to close off fishing zones. This is an example of the 14,000 square kilometers that were closed off earlier this year, just north of our province, Nova Scotia, to lobster fishing. Now, this happened right in the heart of the season and ultimately cost over $12 million to the industry in a period of under less than 2 months. This was catastrophic for people whose livelihoods depend on a very short window season to harvest, and they weren't able to. When you consider the notion of why this was done, it makes a lot more sense, though. You can see drastic rates increasing for entanglements, as well as extending beyond 2014, where 2015 to 2017, 85% of deaths occurred directly from entanglements with fishing gear. However, in 2018, in Canadian waters, where the zone closures occurred, there were 0 deaths this year. So that's a success, but a temporary success because it came at the cost of an entire industry. And so that's where we want to merge those two gaps. We have a model to get to the market too. We're doing our proof of concept testing now, and we're working with fishermen as well as government regulators to determine that we have our Atlas system and our MOBI systems that meet the needs of both sides in particular. We'll be doing additional small-scale pilot testing in next spring as well as next fall to get us to a commercial readiness in early 2020. Now, the overall market model on it, $5,000 is the cost to install an Atlas on a boat. That includes the transducer that communicates to the buoys on the ocean floor, as well as the hauling out of putting in that transducers and the maps. MOBI's at $900 a piece, purchased at potentially up to 130 units. It can get pretty pricey for a large basket size, but we wanted to illustrate the larger customers and how they can have still a very rapid payback period. Now, a lobster fisherman may be purchasing between 30 to 60 of those buoys as opposed to 130, and ultimately making that $120,000, $60,000 or $30,000. We're also working with the government regulators to make sure that subsidies are available to reduce this cost for fishermen. In Canada alone, there's a $170 million whale protection budget that is diverting funds to be able to have fishermen purchase subsidized equipment that can help with whale protection. Now, there are 25,700 crab and lobster fishermen in Canada and the US, and this creates a total addressable market of $3 billion for ropeless fishing. But ropeless fishing isn't a very big category. There are only a few different players. There's ourselves, Desert Star, Edge Tech, and then there's kind of your makeshift solutions. Now, makeshift solutions are good in theory because they can be low cost, but they're not very reliable, they're not practical, and on a large scale, they're not commercializationable. EdgeTech and Desert Star are two interesting competitors as well because they have the technology that exists and they've backed it into the industry, but that's not what it was designed for. They've designed it for other applications and are trying to find this as a different use case. They're working towards developing a solution, but they're not modifying their technology from a fisherman perspective. So they're not practical on the boat, they're not necessarily designed for all weather, and they're not considering the thing that matters the most to the fisherman, reliability. So we've developed a guarantee as well as a directional underwater map and a backup buoy release. This means that they can see their gear, all of the traps that are on the trawl line, as well as retrieve it if the initial signal sent down doesn't work. Breaking this out a little bit more, we include Smelts, which is one other competitor. The only reason we didn't include them in the last chart is they don't have commercial capability as they're not set for trawl lines. It's single trap use, which limits extensively as to how they could scale. But as you can see here as well, with practicality and value, we're scoring higher on the two things fishermen care about the most. We have 6 major milestones before we get to our commercialization stage in 2020. We've achieved our first, and we're completely on pace to achieve everything in our second milestone for fall of 2018. We're in the midst of doing industrial design protection, as well as doing pilot testing later this month, as Aaron mentioned. We have pilots scheduled in March next year, as well as October. In-kind contributions to date, we've received 62,000 in in-kind contributions, whether that's in business services, pilot testing. Fishermen have actually given us deals on their standard rates for testing equipment because they're so confident in the solution being a fisher-focused design, and they appreciate that. So that's been wonderful. And as well, we've received additional rent opportunities from a local incubator that's been housing us for the last little while. And we're crafty with our money. We've only used $63,000 to date, and that has gotten us to a fully working prototype that we'll be able to test with customers. Now, this has been majority in prototyping and production, and we're going to continue this trend for the majority moving forward. If we're fortunate enough to win the $100,000 Neptune Award, this trend will mostly continue, with 60% of our budget being on production and prototyping. Now, this will get us to a point for that March pilot testing where we'll be able to incorporate the next phase of our acoustic transmitter into the system. This will allow that pilot testing to be closer to what the actual commercial application would be, and ultimately provide the fishermen a better use case and ultimately a better understanding of how this could be implemented on a large scale. Funding to date, we received $139,000 in non-dilutive funding over the last 10 months, with specific focus coming from competitions, grants, and subsidies, as well as an incubator that is housing us for our rent as well. As you can see, the $100,000 from the Ocean Exchange would get us to our March prototyping, our March pilot testing that we'll be doing as well with multiple different fisheries across Atlantic Canada. Our 5-year strategy is interesting because this is the first 5 years of the ropeless fishing industry. It's a brand new industry, it's in its infancy, and it's defining itself. And we're fortunate enough to be in part of that definition stage. We're working with both sides, the fishers and the government, to make sure that both of their needs and their regulatory measures can be complied with our system. We see our development curve happening to a position where by 2020, ropeless fishing will become mandated in certain parts of the ocean, where by 2022, ropeless fishing could be mandated in mass areas depending on different extinct species. Now, this is not information that we've just determined. This is information that is believed by both government and fishermen we've spoken with. But besides Atlantic Canada and the Atlantic coast, there are many opportunities across the world. California recently just authorized zone closures as a measure to protect endangered species, and we'll be down in California actually next month to discuss different opportunities on doing piloting there as well. But there's different opportunities around the world considering the number of different trap fisheries as well as endangered species that are becoming linked with those. 140,000 marine deaths per year caused by fishing gear is something that we just cannot let continue. Our team consists of our 3 co-founders, Aaron Stevenson, who has a background in aquaculture, marine diesel mechanics, as well as worked extensively in startup. My background is in social entrepreneurship, as well as in the UN Sustainable Development Goals. Maxwell Poole, our 3rd co-founder, our chief product officer, he's actually from a long line of fishermen. Everyone in his family is in the industry. His brother's a fisherman, his father's a mechanic on fishing boats. So it's in his blood. He understands the pain, and he's really opened up a lot of doors within fishing communities for us. His background's also in big data and market research, and is an expert in that field. Also wanted to give a bit of a shout out to the rest of our team. For any Canadians in the room, you know that this was Thanksgiving weekend in Canada, and they worked all weekend tirelessly to do our testing, and we cannot thank them enough. We're very proud of the work that they've done. In addition to that, we have great partners, 3 academic partners, St. Mary's University, Nova Scotia Community College, as well as Dalhousie University, and 2 engineering partners who work with us on the manufacturing as well as slight modifications on our design drawings as they're done, ingenuity and precise design. Validation, so far we've spoken to almost 200 customers, and that's what's shaped our product. We've not gone and said, here's our technology, do you like it? We've asked the questions on what their pains are from both a government and Fisher perspective to truly develop a solution that can work and be happy. You don't want to develop something that somebody hates you for having to use. You want to feel good about it, and that's why we're working with both sides to make sure that it meets all of their needs and doesn't disrupt all of their processes. We want to make sure it's going to be something that can sustain long term. There are, the 6 UN goals that we directly address are directly in line with our values as well. So decent work and economic growth, that being sustaining these coastal communities with innovative technology, building more sustainable communities around these as well. Responsible consumption and production, we use sustainable materials in the construction of all of our devices, as well as climate change and life below water. We understand that with the number of marine deaths that are occurring and the amount of plastic that gets put out in the ocean, there's no reason that you need to continue that trend. When there are solutions that can resolve the issue of derelict gear being lost and also marine entanglements, we as a society have a mission and a need to do that. At the end of the day, though, for us, it's sustainable communities and sustainable coastlines. We care as much about the marine and the sea as much as we do about the cities that rely on them. Coming from a community that relies on fishing and its economy has been built on lobster fishing, it's important to us. We care about those cities as much as the marine life, and we believe that it's not mutually exclusive to have success with both. And our Blue Glove certification is a promise to all fishermen that we will test all of our products with the gloves that they wear at sea so that they feel comfortable using it, guaranteed. Thank you.
Thanks, guys. So, questions? I've got one. So, that's a pretty rough environment at the bottom of a bay or something, and you say guaranteed reliability. How do you guarantee that? What makes it not foul up or corrode down there?
Really, it's the level of redundancy that we build into.
You gotta get close.
There we go. It's the level of redundancy that we build into it. So it's, and we don't have great distances that need to be covered as far as passing signals through. We don't need a large bandwidth to put it through. So we're able to kind of use a more robust acoustic signal, but we've also incorporated a time-based redundancy into the design as well. So even if there was something preventing the activation, there is still a secondary means of being able to recover the gear. And we believe so strongly in this that we would extend that as a guarantee to the fishermen.
And if a lobster crawled up on top of it, and that wouldn't foul it up. I mean, I'm thinking of just physical things rather than the signal.
No.
Okay, good. Anybody else? Here.
Can you talk about how your buoy system works in there? I'm just, you know, because it's,
Sure.
does it have to inflate because it goes down, so I'm not sure how it gets buoyant.
Okay, so the buoys themselves, they're hard buoys. They're not necessarily inflated. What drags them down is actually the rope containment system. So the rope containment system has a servo that unlocks itself, essentially, allowing the buoyancy of those buoys to then be released to the surface, as opposed to being constrained down below. So it's being anchored to the ocean floor, whereas there's a release plate that allows the basket containing all the rope to rise with the buoys to the surface.
So the traps are fixed then where they're located, so they're attached to the ocean floor? They're not just laying on the O2?
No, they are laying specifically on the ocean floor, but the weight of the rope containment system is able to counteract the buoy system until the servo releases, where the entire rope and water column can then extend to the ocean surface.
Since it's a mechanical system, is there a maintenance factor that has to be added into this that a fisherman has to consider rather than a one-time buy of a trap? That, you know, from a standpoint of maintaining these, reloading them and everything else?
Yes, that's something that we've considered throughout the entire process, is actually the basket that we've designed is directly fitting within the existing hauler systems on boats. So that way it's within their existing processes. It's not, they don't have to stuff it into the system and change things around in that regard. And also in the bottom of the sea, by not having the rope within the water column, it allows the traps and the buoys in the bottom of the ocean not be thrashed around as much and less likely to break and have ultimately a longer lifespan, but the guarantees are on us in that regard. We guarantee that if it gets to a position where your gear is not living to its longer lifespan, we would cover that.
To your left.
So we'll give you the benefit of the doubt. You can put all that cool tech together, and that it will work and that it'll release every time. Your price point at $900 a unit, right, is an aggressive price point for that much tech, right? You mentioned that it was going to require subsidies anyway because it's still more expensive than the regular traps. So the real question I'd love to hear is in your model, what's your product development budget when you start to really raise capital to actually get all that cost down there? Have you modeled that out? Do you know how much it's going to take you to scale this business so that you can actually build several hundreds of these at that price point?
Yeah, so we've based it out to be able to get our pilot testing, which would reduce the costs by about 40% by next spring. But the goal is to be able to have, we'll be raising a $1.25 million seed round at that time, and that will be able to get us to the capacity where we can reduce that number significantly. And then we're also working with the government to be able to have integrated subsidies so that it allows it so that it's not just the retail price is not then slashed down. The retail price is the retail price. Thanks.
Any other questions? Yes.
Okay, well, first of all, congratulations for addressing this issue because it's a lot. It's big. But what is the anti-fouling mechanism that you have? You know, just based on work that we've done at Gray's Reef, our sanctuary here, it doesn't take long for whatever you put on the bottom to become fouled and heavily fouled.
You know, that's something that we're honestly still working through. The add-on, you know, I guess one of the big challenges that we're addressing, especially with this or dealing with, in the Bay of Fundy is has the highest tides in the world, a lot of water moving in and out, and it's a lot of silt. So there is the opportunity not only for biofouling, but for just being gummed up. So we've put a lot of work into and working with our engineering partner firms to help, I guess, design against that and kind of prevent a lot of the silt buildup or getting clogged in. And there's some other things that we can also look at. You know, our good friends over at GIT, for example, that could be a possible solution to prevent the biofouling as well. So it is some areas, but it is going to require more study.
Question over here?
Hi. You didn't talk a lot about the Atlas system and the data that you're getting from it. It's RFID based. So is there a distance? Is there a maximum depth level that you can retrieve that data? I assume you're retrieving it from the surface?
So it's done in actually kind of a couple ways. So currently on our system, it's done where as you kick it, you literally are kicking stuff off the boat. You kick the first buoy off, and then the traps go right after. But once you are able to kind of kick it off directly from there, the Atlas system is recording the RFID tag as it's leaving the back of the vessel, and it's signaling, okay, this particular device is now underwater. Now, the end units that we have are then synced with each of the traps that are on the trawl line. So then those traps are then linked to the main points on either end. So our MOBI system is what's communicating to the surface, whereas the RFID tags are communicating with the MOBI systems on either end of the trawl line, if I explain that remotely well.
I think I got you. So you're not, you can't real time from shore still see whether one of those traps has disappeared. For RFID, you're getting the position when it first goes in the water, and then you're dependent on MOBI from there.
We are working on a sonar solution, though, as well, to have a sonar reflector that would allow for the ability to detect that directly from water and also kind of remove some of the reliance on RFID.
Great. Thank you very much.
And over here, on the right?
So you were saying that if you have an area that's closed because of whale deaths, can you please reiterate, you would be allowed, you have pre-authorization to come in and only using this type of equipment, those fishermen could get their traps and no one else who had the lines would be able to do so?
Yes, part of the closure are worded specifically that it is closed to fixed gear fishing, and that is, some of that is lobster, crab fishing using these traps. So by removing the buoys from the surface and the rope from the water column, it kind of circumvents that type of fishing, and one of the reasons that we've been working so closely with the Department of Fisheries, Oceans in Canada, is they're trying to find a permanent solution that would get around having to use these temporary measures as the zone closures. So this, pardon? And the, our Atlas system also would work with that, so that allows the monitoring or management officers to be able to identify what gear is out there. So currently, the reason that it's kind of the way that the industry is set up, they have to have the buoy along with the identifying information on the surface of the water should an enforcement officer or management officer want to check what gear is there. So with our Atlas system, we're able to provide a subset of that information so they can know what gear is underneath the water, which would, again, allow for the more broadly used application of this technology.
Right now you would be the only people that have your gear underwater that could do this, or there
No,
are other folks?
There is other companies that are doing it. As Ross mentioned, this really is in the infancy. This is something that has, the concept of ropeless fishing has been around. The Woods Hole Institute of Oceanography in the U.S. has been kind of the mainstay in studying this and in researching this for a number of different regulatory agencies. And so the concept is there, but where we really fit in, or where we are innovating in this, is we're the first ones to come and approach this problem from the vantage point of the fishers. So some of our competitors, or most of our competitors, would be taking a traditional acoustic release, which is used in securing sensor arrays to the ocean floor, those types of things, and then putting into this. Whereas, the use case on those is a small number of activations over a longer period of time. So you would take your sensor arrays, you would connect it all up with the release, and you put it down. You would measure for 3 months, 6 months, maybe more, and then come back to retrieve those sensors and take the information from there. Whereas our gear is going to be used, or in this application, the gear has a high number of activations. So this could be done every 8 hours, every 16 hours. There were some cases in the Bay of Fundy where they're going to need to do it every tide, and so it's a high number of activations. But we also get to bring the gear back up on board the vessel, so we can change out batteries, recharge batteries, and the entire season is generally in kind of 3-month chunks of the active season. So we have an opportunity to be able to change out. So it's a very different dynamic and a very different use case than what the traditional or the traditional acoustic releases are used in.
And I just may add that the requirements that the DFO in Canada, Dark and Fisheries and Oceans, that they've set out on what they need, the information that they require to be able to retrieve from the bottom of the ocean, we're the only system that actually is able to provide that information to them.
Thank you.
And just for clarity, because in case not everybody understood, these don't stay on the bottom of the ocean. They're retrieved like any other trap. Can be cleaned, maintained, taken care of. So the question of fouling, it's not like they're always down there.
They're down there at most 3 days usually.
Okay. Anybody else? Thank you. Gentlemen.
Thanks so much.
Great job. Thanks.